All right, this is part 3 of the summer 2017 review for the final exam. We're going to be looking at the next group of problems, starting with number 19. It says express f of x equals negative 3x squared minus 6x minus 5 into the form f of x equals a parentheses x minus h squared plus k, and then graph. So we're trying to put it in vertex form, which has to be done by completing the square. And then once we have that, we should be able to get enough information to graph the parabola. So to start off, we need our x squared to have a 1 in front. So to fix that, because right now it's a negative 3, we're going to pull out a negative 3 out of the x terms. So we'll still have a minus 5 at the end. We're not worried with that. So if we pull a negative 3 out, that would make this x squared, and then negative 6 divided by negative 3 would be positive 2x. And then we're going to have a blank to complete the square inside, and then a counter on the outside. We take half of 2, which is 1, we square that, and then we have to add that inside. But what happened is that we really did negative 3 and positive 1 times each other. So to counter negative 3 times 1, which is negative 3, we need to have a positive 3 added at the end. If we combine all this together, this would be f of x equals negative 3, the trinomial part factors to x plus 1 squared, and this is negative 2. So my vertex would be negative 1 comma negative 2. It's the opposite of the inside number and exactly the ending number. So left 1 and then down 2. And the quickest second point you can get is to just get the y-intercept, because not all of these are going to factor nicely to give you the x-intercepts. So if we plug in 0 for all the x's, it's going to be negative 5. So that would be 0, 1, 2, 3, 4, 5. And because of the axis of symmetry happening at the vertex, which is this point right here, there's going to be a mirror image on the other side. That should be enough to get us a graph. For number 20, we have a couple different parts. We're going to be subtracting these two fraction functions together, these rational functions. We'll be dividing them, composing, and then we're going to talk about the domains of A through C. So let's start with part A, which has us subtract these two fractions from each other. So f of x minus g of x would be 2x over x minus 4 minus x over x plus 5. We would get a common denominator, so we multiply the first one by x plus 5 and the second one by the x minus 4, and that would be over our common denominator of x plus 5 and x minus 4. Distribute on the top, this would be 2x squared plus 10x minus x squared plus 4x over x plus 5, x minus 4. Combining like terms, we get a final answer of x squared plus 14x over x plus 5, x minus 4. For f over g of x, we need to stack this as a division problem. So 2x over x minus 4 all over x plus 5. We would simplify this by multiplying by the reciprocal of the bottom. And because these are monomials across right here, we can cancel out the x. So this would be 2 parentheses x plus 5 over x minus 4. And then composing f with g composed inside. So f of g of x, that is not times, that's the composition circle. So that means we copy the f function as a shell. So 2 times blank over blank minus 4. And then we put the g function into all of those blanks. So this would be 2x over x plus 5 and x over x plus 5 and then minus 4. I would multiply everything by x plus 5 on both top and bottom. So on top we just get 2x. On the bottom we have to distribute this, so we'll have an x, and then we'll have a negative 4 times an x plus 5. So we need to distribute that negative 4. And if we combine like terms, we get negative 3x minus 20. So there's the composition. For part D, we're supposed to talk about the domains of each of these. For adding, subtracting, and multiplying, the domain is always the intersection or the what we call AND version of the two that we already started with. So this says that x can't be 4 and x can't be negative 5. So for adding, subtracting, and multiplying, we combine that to say that x can't be 4 or negative 5. So for part A, the domain is that x can't be 4 or negative 5. For part B, you have to consider the fact that you've stacked this as a fraction on top of another fraction. So there are 3 places where there's issues: the bottom of the top, and both the top and the bottom of the bottom fraction, because they're both in the denominator of this big fraction. So this would be positive 4 again, this is negative 5, but this x on top makes us throw out 0 as well. And then for composition, we have to look at the restriction of the inside function, which is this part right here. So that would be or you could look at the bottom of this fraction as well. So that means that x can't equal negative 5. And we also have to look at the ending result, which is the negative 3x minus 20. So we would set that equal to 0. Add the 3x over, divide by 3. So negative 20 over 3. So for part C, the domain is that x cannot be negative 20 over 3 and negative 5. For 21, we have a prefactored polynomial, and they want us to find all values such that f of x is greater than 0 and f of x is less than 0, and then sketch the graph. Since this is a polynomial, we expect to see a smooth, continuous curve. I'm going to save this so far. We expect to see a smooth, continuous curve with turning points, essentially. And what we care about are a couple things. We care about the end behavior. In other words, at the very last intercepts, are we going down or up on both sides, or are we doing different things? And then the other thing we care about is the intercepts. Are we crossing or bouncing at each of those? So since this is already pre-factored, we have to talk for a minute about the degree and the leading coefficient. That will help us figure out what's happening at the end values. So this is to help us with end behavior. So we have 1, 2, 3, 4, 5, 6. When it's factored, you have to count the powers on each piece. So that would be a degree of 6, which is even. The leading coefficient is negative, so that means that they're even and negative, so that means they're going to be down on both end values. My x-intercepts, or my zeros, are what I get when I set each part equal to 0. So x set equal to 0 would just be 0. X minus 5 would be a 5. And this would be negative 3. The multiplicities for each of these, the 1 at 0 was a multiplicity of 3. The 1 for positive 5 was a multiplicity of 1. And negative 3 was a multiplicity of 2. The odd ones, remember, are going to cross, and the even ones are going to bounce. Now, I did not put these in numerical order, so we need to be careful about that. So negative 3 is going to be a bounce. 0 is going to be a cross, and technically it's a squiggly cross, like x cubed. And then positive 5 is also just going to be a straight cross through. So we're going to plot our points. We know we're down on both ends because of the even degree overall and the negative leading coefficient. So at negative 3, we're going to bounce. So since we're down, we're going to stay down. Then we're going to come up to 0, and we're going to cross as if we were x cubed, so kind of squiggly. We go up, and then we come back down sometime to cross at 5. So when we talk about when is f of x greater than 0 versus less than 0, greater than 0 is when we are above the x-axis. That happens from 0 to 5. All of the other subintervals, we are below the x-axis. So from negative infinity to negative 3, unioned with negative 3 to 0, unioned with 5 to infinity. So only one interval was up, the rest were below. For 22, since they say find the quotient and the remainder, if we have 3x to the fifth plus 6x squared plus 7 is divided by x plus 2, since we're dividing by an x plus 1, we can actually, instead of doing long division, we could do this by synthetic by solving that for x. Make sure you put place values for everything. So 3 is an x to the fifth. We don't have an x to the fourth. We don't have an x to the third. 6 is x squared. We don't have an x to the first. And then we have 7. We bring down the first one, we start multiplying, so that would be -6. Bring it down, multiply would be +12. Bring it down, multiply, we get -24. Add, that would be -18. Multiply, that's going to be 36. Add and bring that down, and then we multiply, that's -72. And remember, the last one is going to be our remainder, so 7 minus 72 is -65. So my remainder is the box at the end. My quotient is all of these numbers down here in this row, but it's always one power less than what you started with when you get there. So 3x to the fourth minus 6x cubed plus 12x squared minus 18x plus 36. For 23, we're only listing the potential rational zeros of the following equation. This is our C over D list. C is our constant at the end. So factors of 36 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. Factors of the leading coefficient, which is D, so that would be plus or minus 1, plus or minus 2, plus or minus 4. Your final answer for this is going to be that you have to list all possible C's over D's, because all it said was list, not solve. So if you put them all over 1, you're just going to get your original list. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. Putting them over 2, 1 over 2 is a half. 2 over 2 is 1. We've already got that. 3 over 2 is new. 4 over 2 is 2. We already have a 2. 6 over 2 is 3. We already have 3. 9 over 2 is new. 12 over 2 is 6. We already have. 18 over 2 is 9. We already have. And 36 over 2 is 18, which we already have. Now we put everything over 4. So plus or minus 1/4. 2/4 is a half. We already have that. 3/4 would be new. 4/4 is 1. 6 over 4 is 3/2. We already have that. 9/4 is new. 12/4 is 3. 18 over 4 reduces to 9/2. We already have 9/2. And 36 over 4 is 9. So as long as you don't repeat any, but you've got the whole entire list, you are good. For number 24, we're supposed to find all of the solutions of the equation. So we list all of our factors again for our C over D list, because this one is not factorable. So plus or minus, at least not using our traditional techniques. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 25, plus or minus 50. Those are factors of 50. Factors of 2 are plus or minus 1 and plus or minus 2. So my potential list to find my zeros from are all of the numbers when you put them over 1 from the top row. And then if we put them over a half, we get a half. 2 over 2 is 1. 5 over 2 is new. 10 over 2 is 5. 25 over 2 is new. And 50 over 2 is 25, which we already have. Then we just start testing these using synthetic division. I would work from the smallest whole integer and work your way up. So 1 is 2, -11, -5, and +50. Bring down the 2, multiply, add the columns, multiply, add the columns, multiply, add the column. So not 0. Try -1. So that's also way off. So it looks like we were a little bit closer with the positive version, so let's try positive 2 next. Bring down the 2, multiply, add the column, multiply, add the column, and then multiply. So we're getting a little bit closer. Just because we got pretty close that time, I'm going to try positive 5 next instead of doing the negative 2. I always kind of follow the path of whatever seems to be getting me closer to 0. Do similar things. So this would be 10, that would be negative 1, that's negative 5, that's going to be negative 10, and that will be negative 50, which is 0. So we already know one of our solutions is x equals 5 because that came from this right here. But there are now going to be 2 other solutions we find using this part at the bottom. So this gives me that 2x squared minus x minus 10 needs to be set equal to 0 and solved. If we use the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's going to be 1 plus or minus the square root of, let's see, that's positive 80 plus 1, so that's going to be 81. So this is actually working out nice. So I'm getting 1 plus or minus 9, because square root of 81 is a perfect square, and then this is over 4. So 1 plus 9 over 4 is 10 over 4, so that's going to be 5/2. And then 1 minus 9 over 4 is negative 8 over 4, which is negative 2. Okay, so there are my 3 solutions. For number 25, we're trying to graph the function. So f of x equals 4 over x minus 6. You can't factor anything, can't reduce. This is a monomial versus a binomial, so we can't cancel the 4 and the 6 out. So we're going to make our list of things that we know. As long as it's already been completely factored, anything in the bottom that causes a 0 is going to be a domain issue. X-intercepts only occur if there's a x in the top that hasn't been canceled out, so they're none, so there are going to be no x-intercepts. Y-intercepts you find by plugging in 0 for all the x's. So that's going to be negative 2/3 if you work that out. So that would be 0, negative 2/3. The vertical asymptote is whatever is in the domain that didn't cancel out. If it canceled out, it would have been a hole. So x equals 6. There are no holes since no x is canceled out. And the horizontal asymptote, remember, is found by long division. X minus 6 does not go into 4 at all, so it's y equals 0. If that had given me an x in that answer, remember that would have been an oblique, but we don't have an oblique if we have a horizontal. So let's plot what we know. At positive 6, so 1, 2, 3, 4, 5, 6. So I'm kind of off-centered a little bit here on my graph. I have a vertical asymptote. At y equals 0, I also have a horizontal asymptote. And then I have that at 0, negative 2/3 is my y-intercept. And I want some other points. So I'm going to pick some points on both sides of that vertical asymptote just to get some better shape. So maybe since this is at 6, I'll pick, let's say, 3 and 4, and I'll pick 7 and 8. So we plug those in. 4 over 3 minus 6 is 4 over negative 3, so that's negative 4/3. 4 over 4 minus 6 is 4 over negative 2, so that's negative 2. 4 over 7 minus 6 would just be 4 over 1, so that would be 4. And 4 over 8 minus 6 is 4 over 2, which would just be 2. So let's plot what we have. So 3, 1, 2, 3. Negative 4/3 is a little bit less than, or a little bit smaller than negative 1. 4, negative 2. 7 up 1, 2, 3, 4, and 8 would be at positive 2. So what it looks like is that our graph is bounded in the bottom of this part, and then in the top on the other side. And there's our graph. All right, let's graph the function. A little bit more difficult one. This one actually has some factoring that can be done right off. This is 3x squared over x plus 3 and x minus 3. So I have nothing that cancels out, but my domain is going to have two restrictions this time, so -3 and +3. X-intercepts. I do have an x on top, so 3x squared equals 0 when x equals 0. So this would be x-intercept of 0, 0. If that's ever your x-intercept, it's also your y-intercept. If you plug in 0 for all the x's, you get 0 on top. We don't have any holes because nothing reduced out. Let's see, vertical asymptote, x equals -3, x equals +3. Horizontal versus oblique. If we do long division, x squared minus 9 into 3x squared. X squared goes into 3x squared 3 times. No x's on top, so that's going to be a horizontal at y equals 3, which means none for the oblique. So 0, 0 is definitely a point. 1, 2, 3. +3 is a place where we're going to have 1 vertical asymptote, and x equals -3 is the other vertical asymptote. Then we also have a horizontal asymptote at +3, so y equals 3. And we don't have any other points, so we're going to need to pick some things. Notice there's 6 real regions here that we need to worry about. The left of -3, in between -3 and +3, and then on the right of +3. So I'm going to, since this is really low here, I'm actually going to pick a couple points in between to make sure I see what that's doing. And then, so this is -3, so I'm going to pick -5 and -4. That will be on the left of -3. In the middle here, I'm actually going to pick 4 points. I want to know a little bit more about this graph. So I'm going to pick -2 and -1, and then 1 and 2. And then on this side, we're going to pick 4 and 5. Okay, so if we plug these in, 3 times -5 squared over -5 squared minus 9. That's going to be 3 times 25, so that's 75 on top. 25 minus 9. And all we have to get is a decimal approximation here is 16. So 75 divided by 16 is 4.6875. And that's also going to be the answer for +5, because when all the x's are getting squared, they're -5 and +5 are both going to give you 25s. Okay, so let's do 4. That's kind of why I picked more points, because you don't have to work all of them out because of the squared part. So the top would be 16 times 3, so that's 48. And then 16 minus 9 is 7, so divided by 7 is 6.857. We're rounding there. Okay, so then we plug in -2. So -2 squared would be 4, times 3 is 12, divided by 4 minus 9, which would be -5. So that's -2.4, and that's going to be the same for +2. And then -1 would be 3 on top, divided by -8, -0.375. Okay, so it looks like what we're getting here is, let's plot these points. -5 is at 4.68, so that's almost at 5. -4 is at 6.8. So that's up here. So it looks like this region is staying up here in this top corner. -2 is at -2.4. -1 is at -3.75, so that's pretty small. So it looks like this is headed down. +1 is kind of mirroring that. And then we get kind of a mirror image over here as well for the other side. So we are at 6.8 something for +4 and 4.68. So there's our graph, and that is going to be the end of part 3 because that is the end of the material we covered up to Unit 3.